Today our topic is to learn about nth root of a complex number. Nth root of a complex number. Of a complex number, right? Okay. Then, for example, if you want to get this one, suppose that if z cube is equals to 1, then if you want to find the value for z, the question is solve this one. So you can say this is the cubic root of 1. So simply in our small grades we just get to this and one as z equals to just only 1. But that is not only the answer. This is one answer obviously. There are several answers when you are considering about this complex format for cubic root of 1. So for the moment the thing what you have already learned is only the part of the answer. So let's see how do you find the solutions for this cubic root of 1, right? This is the way of doing this question. So initially we will get z is equals to z cube. You have to solve this equation z cube equals to 1. Initially we will write this 1 as a complex number. We know that we can say 1, you can write 1 plus 0i. That's the simplest way of getting this answer, right? Okay. Then if you mark this on a Argand diagram, that is this way. So it's 1 over here. So if you write this fact, the complex component for this one is modulus of z. If you work out the modulus of z, that is obviously 1. And the arg z, how much of arg z? Angle over here is 0. Therefore, you can say z cube is equals to 1 cos 0 plus I sin 0. As a result, we can write the general format. General format. What do you mean by the general format is, children? You can say one complex number is like this. You can say over here. Then after rotating with 2 pi even, again you come up to the same point. If you get another circle, again you get the same thing. Again you can write the same thing as well. Therefore, for this complex number, can't I write this way? You can say cos 0 plus I sin 0. I sin 0, sorry. Right. Then we can say this answer as well. Cos 0 plus 2 pi plus I sin 0 plus 2 pi. If you write in this way, even doesn't make a difference because you can say that it's after moving a one circle, even it comes to same thing. The next one is cos 0 plus another 2 pi, that is 4 pi plus I sin 0 plus 4 pi. This way even you get the same mass after rotating for two circles, even it come up to the same point, right? Okay. Therefore, you can write the general answer in this format. Z cube is equals to 1. You can say cos 0 plus 2 pi n plus I sin 0 plus 2 pi n. 2 pi n means if you put you can replace this n with 1, 2, 3, 4, you get the same answer somewhere like this, right? Then we will get z. I just do the same thing. You can say this is 1. This is cos 0 plus 2n pi plus I sin 0 plus 2n pi to the power how much? 1 over 3. Then if you apply the De Moivre's theorem, what do you get? You can say this is 1 to the power 1 over 3 times of this bit, you can say cos 2n pi over 3 plus I sin 2n pi over 3. This is the answer for that, right? Then when you get the answer over here, this answer, then what you need to do is, whatever the in a complex number, we know that theta, arg z, should be in between where to where? Minus pi to plus pi. What do you mean by this angle? So you can say that when you mark this on an Argand diagram, the complex number, if you mark on an Argand diagram, the complex number is, you can mark like this, and this way. So the angle over here should be maximum up to this. That is what you mean by value over here. For the negative sides, you can say that the maximum angle you can go up to here, that is minus pi. Therefore, whatever the arc z what you obtain over here should be in between where to where? Minus pi to plus pi. That's what you need to understand, right? Okay. Now let's see how do you get this answer. So initially we can replace different n values. So I will vary like this. N I'll vary 0, n equals to 1, n equals to minus 2, like that. For the other side even you can apply 1, n equals to 2, like that. If you know that from our basic principles, if it is a cubic root, how many solutions you can get? If it is a square root, you get only 2 answers. If it is a cubic root, how many answers you get? You get 3 answers. If you get fourth root, you might get maximum of 4 answers. Like that, here you should get 3 answers, but if you can just randomly figure out these figures and to put it. Right. Initially work out over here. What happened when n equals to 0, right? Then if you put this answer, first solution is z1. If you put 0, that is cos 0 plus I sin 0. So simply what you can say, this is obviously the same thing, it's 1, right? Then if I put it over here, what do you get? I just said 2, I'll mark it as. So this is 1 cos 2 pi by 3 plus I sin 2 pi by 3 here. So this is the one answer. So we know that cos 2 pi by 3. Yeah, cos 2 pi by 3 is minus half. So this is minus half plus root 3 over 2i. That's the second answer. Third case is this way. I'll just mark like this. 1 cos 4 pi by 3 plus I sin 4 pi by 3. So what can you say about this answer? Obviously this answer is bigger than pi. Therefore, you cannot obtain this answer over here, right? Then if I put z this way, so I just like this. 1 cos minus 2 pi by 3 plus I sin minus 2 pi by 3. So what do you get this answer over here? So you can say this answer turn up into you can say this is minus cos 2 pi by 3 is minus half minus root 3 over 2 I. So these are the 3 solutions for this. So you can say the solutions are z equals to 1 minus 1 over 2 plus root 3 over 2 I. The other one is minus 1 over 2 minus root 3 over 2 I. That's a These are the 3 answers where you obtain as a cubic root of 1, right? Okay, that's how you need to do this question. Hope you can understand, right? Okay, yes. Then let's move up to the next question, right? It's like this. Okay, we will come up with another example just like this. We will get this one. They ask us to solve z to the power 4 equals to 2 plus 2 root 3 I, right? So initially what you need to do is mark them in a Venn diagram. This is 2 and this is 2 root 3, like this way around. So it's just like this. Therefore you can get the modulus of z become 2 root 3 whole thing squared plus 2 squared, the square root of it. So that is turn up to how much? 4. Then we can get arg z. Arg z is here, theta. So you can say theta equals to tan inverse 2 root 3 over 2. That is pi by 3. Right. Arg z is pi by 3. Therefore you can say this answer is z to the power 4 equals to 4 cos pi by 3 plus I sin pi by 3. Right. Then you can say the general answer for this is 4, as I mentioned over here, cos 2n pi plus pi by 3 plus I sin 2n pi plus pi by 3. Okay. Then you can say z is equals to 4 to the power 1 over 4. This way, if you apply the De Moivre's theorem, the power 1 over 4th root come. So this is turn up to cos 2n pi plus pi by 3 divided by 4 plus I sin 2n pi plus pi by 3 divided by 4. So you can say it's like this. Okay. Then you can say z is equals to 4 to the power 1 over 4. 4 to the power 1 over 4 is equals to root 2. Right. So here it will turn up to cos n pi over 2 plus pi over 12 plus I sin, this is n pi over 2 plus pi over 12. Right. Okay. Then what you can get here is, you can say this is then we will work out for n equals to 0. If I put n equals to 0, you can say z1 equals to this turn up into 0 and this one also turn up to read 0. Root 2 cos pi by 12 plus I sin pi by 12. So if you want, you can find this cos pi by 12 and you can work out this answer, or you can write the exponential format root 2 e to the power pi by 12i. You can say the answer in this way, or you can write it as a what do you call that, you can find cos pi by 12 and multiply with root 2 and you can do this extension. That way also possible, but it depends on the way they ask you the question, right? Then I will replace with n equals to 1. Then what do you get? Is it 2 equals to root 2. Then if I put 1 here, pi by 2 plus pi by 12, that will turn up to 7 pi by 12. Cos 7 pi by 12 plus I sin 7 pi by 12. So here you can say this is root 2 cos 7 pi by 12i. So that's the second answer. This one also possible because it's not exceeding 2, right? So not exceeding pi. So if I put n equals to 2, what happened here? Let's put it to see and then it is pi by 2 divided by 2 is pi plus pi by 2 definitely exceeding. So therefore you cannot write the answer for n equals to 2, right? Then we can work out n is equals to minus 1. So it will turn up to this way, right? Then this is root 2 cos, if you work out over here, so what you can understand, minus pi by 2 plus pi by 12. So if it is minus 1 minus pi by 2, so that is cos minus 5 pi by 12 plus I sin minus 5 pi by 12. So this is turn up into root 2, this is not cos, this is e to the power minus 5 pi by 12i, right? Okay, that is the second answer. Then we'll go ahead with n equals to minus 2 also. Z3, Z4, right? Okay, root 2, this is turn up to, how do you get it, Pate? So this is turn up to, if you put 2 here, minus pi plus pi by 12 is minus cos. Hope you can understand. 1 second, we got a kind of a technical failure. Yeah, so let's function further, right? Okay, then you can say this is cos minus 11 pi by 12 plus I sin minus 11 pi by 12. So this is turn up to root 2 e to the power minus 11 pi by 12i. So that is how you need to work out for this question. Hope you can understand how I get this answer. Right, okay. So this is the way of finding the roots of a complex number, right? We will go ahead with another one more example and try to understand how it is supposed to do this kind of a question, right? Okay. Then if I want to find the solutions for, if they have given a question like this, z to the power 3 is equals to, we will get this answer in this way, root 3 minus 2i. This way around. Right. Then we can understand that this is this way. So root 3 is over here. Root 3. 1 second. Hello. Okay, children. If you need to find the solutions over here, you can say this is root 3 and minus 2 is over here. Therefore, if you work over this way, you can say the angle over here. So if you get the modulus of z is equals to